How you doing today? We are in chapter 7, and on page 307, we are looking for non-membrane processes for secondary treatment. So when we look at treatment, we have a variety of options. We have suspended growth, and when we talk about suspended growth, really we're talking about those traditional aeration plants with mixed liquor suspended solids. And then attached growth, we're looking at an RBC, rotating biological contactor, or a trickling filter. So, or or as they mentioned, some sort of hybrid process. So, if you've taken my um, wastewater course, you'll have an idea of what we're talking about. But let's look at a couple of these. So turning on page 309, you have your standard primary clarifier, and then your aeration tank, and your secondary clarifier. We've talked about this in wastewater treatment, but as the solids come in and the influent from the wastewater comes in, it goes through the primary clarifier, it settles out or floats, and those are taken out of the system. Then we introduce that water that comes out of the primary clarifier into the aeration tank, and that's where we get our phosphorus, nitrogen, and CBOD removal in the aeration tank. And then in the secondary clarifier, we're getting the separation of the mixed liquor and the clear water, which will actually um, be then discharged to the river or the stream. You can see on 309 you have your conventional plug flow or your step feed aeration, um, an oxidation ditch, which is very similar. Um, to an aeration tank, except that it is, I basically call it like a creek. It's an aeration creek. And what happens there is there's rotor and brushes, and it brushes the mixed liquor, causing air to be introduced into that oxidation ditch. And then the mixed liquor comes in contact with the influent, as you can see, treats the influent for CBOD, ammonia, phosphorus, nitrogen, all those parameters. And then once again, the sludge separates from the secondary clarifier and then goes back to the influent. Another system is a batch suspended growth system, and that's really your SBR plants. So they're called the sequence batch reactor, and I actually got to operate one of these out in Iowa. And what happens is, instead of having a clarifier, your tank acts as your aeration tank and your clarifier. So the way it works is the waste comes in, fills into the tank. The mixed liquor then reacts with the waste for 90 minutes, depending on what kind of SBR you have. It treats the waste. You shut the air off. It settles. The mixed liquor will settle, and then a decant arm will flip out or open, and you'll take the clear out. The decant arm will close, and then the process starts all over again. Really depending on what you have, whether that be a membrane process, a non-membrane process, like we discussed with suspended growth. A lot of that has to do with what is the constituents of your waste coming in that you want to reuse, and then what are you wanting to reuse that for. And so your technologies really don't be driven by those kind of constraints. Plus it will also be driven by just the physical layout that you have. Maybe you don't have a lot of land, and you have to go to a more compact and concise piece of equipment just because your physical layout is not adequate to support a big big plant. And you can kind of see that, especially when we're talking about these smaller um, satellite plants or decentralized plants for water reuse. A lot of these may be in tight urban areas where you need technology to do more with little or space. And so that's those some of the things that we think about. On page 313, you can see a trickling filter. I recommend that you maybe watch a video on aeration, a YouTube video, or watch a video on trickling filters. So the way the trickling filters work is the waste is distributed on top of the trickling filter, and as the waste zigzags through the rock media or the synthetic media, it picks up air, and microbes are actually living in um, the rock features of that trickling filter, which is why they call it attached growth, because there's actually growth there on the filter. We call it a filter, but it's not actually a filter because it's not necessarily used to filter out solids. Is more to remove your CBOD, BOD, and ammonia that you have. Moving right along, nitrogen removal. Are you going to need nitrogen removal? On page 322, this is kind of a plant that I have. It's on 322. It's the step feed bee, the bee plant. We don't really have the step feed portion of that, but what we have there is anoxic, aerobic, anoxic, aerobic, anoxic, aerobic. Um, what you're trying to do right there is, take ammonia and release it in nitrogen gas. And when you go from those aerobic to anoxic zones, that's really what you're trying to accomplish there. Is 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 the release of that. Obviously, for removal, for phosphorus removal on 327, you do it by chemical addition. So, right there on A, you add some sort of chemical, polymers in conjunction with alum and lime as flocculants. So you would add some sort of chemical, and then you're trying to create your soluble phosphorus into insoluble to precipitate out. Um, our next, which is up and coming, is an MBR. I believe this is one of your test questions, but they can be vacuum driven or they can be pressure driven. Um, there, I think these will become more and more as technology increases, but it uses a membrane there with some sort of osmotic pressure there to separate the mixed liquor um, from the water. So once the waste has substantially reacted with your CVOD, uh, ammonia, nitrogen, phosphorus, all that stuff. Um, and you want to separate, you actually want to get the clear out of your mixed liquor instead of like a clarifier. Then you would use a semi-permeable membrane and use some sort of pressure to apply to that to remove that. Um, Moving along, you can kind of see a submerged membrane plate on 355. I think we've talked about a lot of these. I think our um, next one that we're going to go to. Um, I think one of your test questions is on 361. It's issues and selection of secondary treatment process. So it says some of the issues that must be considered are expansion of the existing or construction of a new plant, Once again, the final use of the effluent, comparative of various technologies, results of a pilot plant study, type of disinfection process, future water quality requirements, and energy considerations, site constraints, and economics. Before we invest a lot of money in water reuse to treat the water, we need to know, is it economically feasible? Do we have the area? Does the pilot studies show that the equipment that we've chosen can adequately treat the water so that we can use it in water reuse? So those are all kind of things that we, thoughts that we need to go through before selecting a uh, a product. Well, that's chapter 7 in a nutshell. Reach out to me if you have any questions. Thanks.